at solving simultaneous equations. In problem 1, we need to do that using the graphical method. So I've got an equation 2x minus y equaling 4, and I have x minus 2y plus 1 equaling 0. I need to find the value of x and y that satisfies the first equation, and at the same time satisfies the second equation. The first equation, and I'm going to show that as being green on the Cartesian plane, is this. And I just need to manipulate it into a format that I can easily graph. So I've rearranged it so it's y equaling 2x minus 4, which of course is a straight line graph. And the second equation can be rearranged so it becomes y equaling a half x plus a half. And with a straight line graph, I just need 2 points for each of them so I can rule a line between the two and show it graphically. So with the first equation, I've got x equaling 4, which produces y equaling negative 4. And if I allow x to equal 5, that will mean that y is equal to 6. The second equation, I can find 2 points as well. So if I have x equaling 0, I've got the position 0, a half. And another point that fits on this equation is x equaling 5, y equaling 3. So I draw up a Cartesian plane. And for the first graph, I put my 2 points in and then rule a line. Second graph, the same approach. And what can be seen here is that with the first equation, there's an infinite number of points which make that equation work. And with the blue graph, there's also an infinite number of points which make the equation work. But there is only one point, and it's here at the intersection of the two graphs, that make the first equation work and then at the same time make the second equation work. And that's the position 3, 2. So that satisfies both equations simultaneously. And that is the solution for the two equations. So what that means is that if x equals 3 and y equals 2, the first equation will hold. So that is that the left-hand side will equal the right-hand side, so the left-hand side will equal 4. And at the same time, for x equaling 3 and y equaling 2, the second equation will hold. So that is that the left-hand side will equal 0 and the right-hand side will equal 0. And that's the whole idea of simultaneous equations. Okay, another technique for solving systems of simultaneous equations is the substitution method. So I've got the same equations as I did have in problem 1. Here's my first one. And again, I rearrange it, so I've got y being the subject. I now take a look at the second equation. And here it is here. And what I want to do is rewrite that equation, but instead of having x's and y's, I want to just have one variable. And over here, I know that y is equal to 2x minus 4. So I'm going to rewrite this equation, but instead of having that y, I'm going to have what y is equal to. And y is equivalent to 2x minus 4. So I'm just going to put in the 2x minus 4 here. Now I have an equation with just one variable, that is the x's. So I expand the brackets, collect like terms, add 3x to both sides, divide both sides by 3, and I produce that x is equal to 3. I now need to work out the y value. So I know that y is equal to 2 lots of x take away 4. There's equation 1. So I substitute x equaling 3, and I produce 2. So I now know that the solution for this set of simultaneous equations is 3, 2. We also have an elimination method. So if I now consider these two different equations, the way that we set this up is like so. So we write the first equation, and then underneath it we write the second equation. I call the first equation equation 1 and the second one equation 2. Now the objective here is to try and get either the x's or the y's to be of the same size and then do a subtraction or an addition. Let's see how we go. So what I'm going to attempt to do is try and make both the top line and the bottom line so that we have 10x and 10x. So looking at the first line, and remember I refer to that as equation 1, I want to take that equation 1 and multiply everything by 2. So if I do that, I get 10x plus 6y equaling 6, and I'm going to refer to that as equation 3. The second line, to make the 2x 10x, I need to multiply everything by 5. So I take this second equation and multiply everything by 5, and you can see I've produced this here, and I'm going to refer to that as being equation 4. In my next move, I take the top line and I subtract the bottom line. And what will occur is that the x's will now be eliminated, hence the name. Meaning that I'll have an equation with only one variable, which I can easily solve. So here I'm going to take equation 3 and subtract from it equation 4. 10x take away 10x is 0x. 6y take away negative 10y becomes positive 16y. And 6 take away negative 35 becomes positive 41. Divide both sides by 16 and I end up with y equaling 41 on 16. Now I can use either equation 1 or equation 2 to work out what x is. So I've just used equation 2. And of course I know that y is equal to 41 on 16, so instead of writing in what y is here as just a variable, I write exactly what it's equal to, which is 41 on 16. And then it's just a matter of rearranging things so I can work out the x, and x ends up being negative 15 on 16. So the point on the Cartesian plane which satisfies both the first equation and the second equation is negative 15 on 16, comma, 41 on 16. 4. We're going to be applying the algebraic and graphical techniques for solving simultaneous equations, but this time we're going to be making use of the CAS. I'm actually going to start with the algebraic technique. So here's my two equations, and we've used them previously. So getting to my CAS, I can just go menu, and I want a calculator, and let's make use of the solve function. So menu, algebra, and solve. And now I'm going to put in the two equations. So I'm just going to use the template. So let's click on here, and I want two equations. So the first one is 2x minus y equaling 4. And the second equation is x minus 2y plus 1 equaling 0. And I'm solving for x and y. That produces 3, 2. Notice that with the solve function, I could also write the word and between the two equations. But in this format, having one above the other, you can see exactly what's going on. Everything's really clear. It's a bit quicker. So I could have used the word and. So this is the syntax that you put into your CAS if you're making use of the word and you literally just type that. All right, with the graphical technique, I'm just going to take you through the steps and then demonstrate that as well. I've got my two equations, and the very first thing I need to do is manipulate the two equations so that y is the subject. And that way I can put it into my CAS calculator. So I do that. My second step is to graph them. And in the third step, I want to look for the intersection points. So there's obviously a little bit more work in this technique to do it graphically. So I'm going to go menu, algebra, and solve. I'm going to put in the first equation, and I'm going to solve for y so it rearranges the equation. So 2x, take away y, equals 4. And I'm solving for y. And you can see it's rearranged, so the right-hand side is 2x take 4. And again, similar technique, menu algebra solve. I put in my second equation, x take away 2y plus 1 equaling 0. And I'm solving for y. And the right-hand side is x plus 1 over 2. Now I need to use the graphical approach. So I'm going to hit the home screen and I put in the two graphs. So the first function on the right hand side was 2x take 4. There's that shown. And the second, the second one was a fraction. And at the top I had x plus 1 on 2. There's my second. And obviously this is the intersection point. And I know it's going to be 3, 2, but let's just verify that. So menu, geometry, points and lines, and then I want intersection points. So just to show you that again, guys, sorry, it's a bit confusing there for you. I want menu, analyze graph. No, I don't. I want geometry, points and lines, and then intersection points. We hover over the first graph and select it, then we hover over the second graph and select that, and that produces a solution 3, 2. Now obviously if you're using your CAS calculator and it doesn't stipulate for you to use either the graphical technique or the algebraic technique, clearly that first one there is the most efficient way of doing it, and I recommend that you do that. I'm just showing you how the CAS can be used as well for the graphical technique.